Welcome to this Master Plumber Licensure Review session, presented by JCB EduBuild Solutions. I am Engineer James Bolo. A building's drainage network is a continuous pipe leading directly into the public sewer. Without mechanical intervention, this creates an open pathway for toxic methane gas to flow back indoors, and a channel for municipal infrastructure clogs. We secure this pathway using two strictly regulated mechanical devices. Traps act as the barrier against harmful gases. Interceptors, or clarifiers, defend against dense solids and coagulating oils. Today, our objective is to map the specific physical laws and the exact numerical sizing parameters governing these devices, as required by the revised National Plumbing Code for your upcoming board exams. Mastering the plumbing code is an exercise in applied physics, designed to isolate human habitation from catastrophic system failures. The code mandates a strict frontline defense. Every single plumbing fixture must be separately trapped by an approved water seal trap, unless the fixture possesses an integral trap of its own. To calculate the required liquid volume, we define specific anatomical landmarks on the pipe geometry. The upper boundary is the crown weir, the lowest point of the trap's internal upper curve. The lower boundary is the top of the dip at the base. The trap seal is the maximum vertical depth of liquid retained precisely between these 2 points. The code demands exact dimensional tolerances here. This trap seal must measure no less than 51 millimeters and no greater than 102 millimeters deep. There is a precise exception for multiple fixtures. A single trap may serve up to 3 single-compartment sinks or lavatories, provided they are in the same room, immediately adjacent, and their waste outlets are spaced no more than 0.75 meters apart. Furthermore, the vertical distance between a fixture outlet and the trap weir must be kept as short as practicable. In no case can the tailpiece from any fixture exceed 0.6 meters in length. The structural integrity of that exact 51 to 102 millimeter volume of liquid is the primary barrier standing between human habitation and lethal sewer gases. The code prohibits any trap geometry that compromises the seal. S-traps, bell traps, and crown-vented traps are strictly banned. These specific designs rely on concealed partitions or interior curves that make them highly susceptible to self-siphonage. The rapid flow of wastewater creates negative pressure, pulling the liquid seal entirely out of the pipe and leaving the gas pathway open. To prevent this, every fixture trap must be protected against siphonage and back pressure by a properly placed vent pipe, ensuring constant air circulation. This brings us to the trap arm, the precise distance from the trap weir to the inner edge of that protecting vent. This table dictates the maximum allowable length for that arm, which is strictly limited by the pipe's diameter. You must commit these limits to memory. A 32 millimeter trap arm has a maximum developed length of 0.76 meters. A 76 millimeter arm can extend up to 1.83 meters. There is also an absolute lower limit. The distance from the trap weir to the vent can never be less than 2 times the diameter of the trap arm itself. If the trap arm needs to change direction, any bend up to 90 degrees requires no cleanout. However, for trap arms 76 millimeters and larger, any change of direction exceeding 22.5 degrees mandates a cleanout at the bend. As wastewater moves through the pipe, it drags air with it, creating internal pressure zones. The strict limits in Table 10-1 exist to ensure this air movement doesn't create a vacuum strong enough to pull the 51 millimeter liquid seal out of the trap. Standard traps fail when a building's wastewater introduces flammable liquids, highly acidic waste, heavy sand, or massive volumes of commercial grease. In these high-hazard scenarios, the code mandates the installation of interceptors or clarifiers. These devices utilize specific gravity and calculated retention time to separate deleterious matter from normal sewage. By design, all interceptors must be readily accessible for cleaning, vented to prevent air binding, and engineered with a water seal significantly deeper than standard fixtures. It must be no less than 152 millimeters deep. Commercial grease traps are specifically required in restaurants, cafeterias, and meatpacking establishments. They isolate fats and oils before they can cool, solidify, and paralyze municipal sewage treatment systems. This table details the exact capacity rule. The total capacity of all fixtures discharging into a grease trap cannot exceed 2.5 times the certified liters per minute flow rate of the trap itself. For fully equipped commercial kitchens, we calculate the required interceptor volume using this formula matrix: meal served at peak hour, multiplied by the waste flow rate, multiplied by retention time, multiplied by the storage factor. Operationally, the code enforces absolute prohibitions here. Food waste disposal units cannot discharge into any grease trap. Additionally, water-jacketed grease traps are entirely prohibited. Adding a central interceptor does not override upstream requirements. Every individual fixture discharging into a grease trap must still be individually trapped and vented in an approved manner. Interceptors function as the building's downstream immune system. They utilize targeted fluid dynamics to forcefully isolate physical blockages before they breach the public municipal infrastructure. In sanitary engineering, we utilize two distinct lines of defense. Traps protect the building from the sewer by blocking gases. Interceptors protect the sewer from the building by isolating hazardous solids and oils. As you prepare for your board exam, verify your parameters: the 51 to 102 mm trap seal, the 152 mm minimum interceptor seal, the absolute ban on S-traps, and the specific geometric ratios detailed in tables 10.1 and 10.4. Success on the licensure exam depends on recognizing that these codes are the direct application of fluid pressures and specific gravity to a building's infrastructure. Thank you for joining this specialized review session and committing your time to mastering these systems. I am Engineer James Bolo. On behalf of JCB EduBuild Solutions, we wish you absolute success on your upcoming board examinations and in your future engineering practice.